Awesome, awesome, awesome. This is great. I'm seeing a lot of people that have recently signed up for the free version or like some of our legacy users, and that's awesome to see that people are joining in. So thank you guys for coming in. A lot of these people, almost everybody on this list that we haven't explicitly spoken to. So this is a really nice way to kind of get everyone on. So again, thank you, Advanced Assembly, for setting this up. Obviously, should do a quick intro on AA. Lisa, I don't know if you want to do that or I can do that.
You can go ahead and do that, Mihir. That's fine.
Yeah. So basically, Advanced Assembly, they're, I mean, disclosure, but also kind of a proud moment for us. They're one of our biggest investors. They are, because we've been using them forever, / we're just directly tied in with them, arguably the fastest quick turn PCB fab and assembly shop in the US today. Difference between them and almost every other assembly shop that you may have ever used is they're not a broker in any capacity. Same ownership owns them, owns board shops. They have a direct tie-in. They're not kind of using the board shop to add a big profit margin. It's a really nice way that they run the business to basically streamline it. Come to them for turnkey. They'll get you boards, assembly, parts, and do it all within a day, 2 days, 3 days. So it's really nice kind of working with them and getting your stuff taken care of, especially during trying times like these where everything else seems to be delayed. They're still running because they're doing mission critical work for a lot of kind of medical devices that are working against COVID-19. So if you guys want to kind of get in on that and use it to your advantage, Advanced Assembly is totally up and running and operational, and obviously forward thinking to the point where they went ahead and invested quite a lot of money into InspectAR. And so just kind of a way that when you're working with a team like Advanced Assembly, it's not your stodgy old board shop or assembly shop, totally forward thinking, software driven, arguably the most automated shop in the US today with some of the most lines in a building that I've seen, way more than 2 or 3. It's a nice operation. So thank them a lot for kind of putting this stuff together. And I guess it's a clear testament to people that listen into them because there's way more people on this call than I would have expected. So that's really, really awesome to see. So that's a little bit on AA, full turnkey PCB fab assembly, prototypes, no minimum quantity, ultra fast turn times. Now a little bit about InspectAR. You know, we've done hundreds of demos to customers over the last couple months, more really. And I think the biggest thing we've learned is we can give the longest introduction we want. People don't get it until they see it live. And so let's give it another 2 minutes. Let it get to 11:05. Sorry guys, but it'll be quick after that. And then let's go from there. Cool. So, and yeah, so, you know, we'll go over kind of like how we set up the business so far, but basically, because again, we're a small team, 10 plus people, we put out a free version so people can immediately get a feel for it on their mobile devices, iPad, phone, Android, whatever, iOS. And then we have a professional version that works on your custom PCBs, and we're doing a pilot program right now. So like anybody can go ahead and try this out with their own boards. Just email us. We want to give you this demo. This kind of serves as that. And we'll give you guys unlimited licenses within your organization. Try that for a few months, and then let's figure out how to get into your workflow and go from there. But that's how we're doing things right now. We have a lot of kind of happy and dedicated customers on that service right now. And it's been really great in helping us with product development and saving them a lot of time in the lab, especially right now with remote collaboration. But without any further ado, let's get started.
Awesome. All right, guys, let me just clear things away. So InspectAR is a tool that changes the way that you interact with circuit boards. So if we look at this Bluetooth development board that we have down here right now, if you wanted to interact with this board and say you needed to find out some information about this big IC that I'm mousing over right here, normally what you would have to do if you were starting from scratch is go into your schematic, find that component, see what nets it's connected to. Then you could move over to a layout drawing or layout software. You can look at the footprint there, see what pins are connected to which net and which one you need to go and probe. And then finally you move over to this board where you find this IC, no problem, but then you've got to painstakingly count up each one of these pins. But with InspectAR, we really change all that because now you can just mouse over the component, select add component, and then we'll give you the net list and pin out overlaid in real time. So now as we scroll over each pin, we highlight it for you so you don't need to waste a bunch of time counting them up and then probably making a mistake in your measurement. you can just find them in real time. And if you need more information about what something is connected to, you can just right click, select create attached net, and then we'll create that circuit for you in real time. So this is really powerful in just changing the way that you interact with your hardware, because now you can go and interact with the board directly instead of having to go back through all of your documentation in order to find out more information.
And to be clear, that's a physical board that Liam's looking at. And so
Yeah.
that's on the desk. It'll move and kind of move with you. And make sure that your guys, you flip the board over, it'll work just fine. And make sure that you guys can see the right side of the actual UI. So if there's any cameras, like our faces are kind of blocking it, just drag it up or hit escape and make sure you're kind of on a smaller side of the screen. But basically, like Liam was saying, this is the tool. You can highlight any net component or layer, and I'll let you kind of take the stage from here.
Yeah, so we also integrate with your BOM to pull in more part information. So right now, if I hit request part info, we'll actually go and query DigiKey to pull down all the information about this IC. So here you can see there's all the specs that DigiKey would normally list for this component are displayed right here in the info pane. If you need to get into the data sheet, that's no problem. There's a PDF viewer built right into the tool. So you can open up the data sheet, and then as soon as it loads, you can browse through it just like you normally would. You got all the features that you would normally expect to be able to go and interact with this. And then when you're done, you can minimize that and it will just lock down to the bottom there on a taskbar. And you can have several of these open and they'll just stay down there so that you have them for quick reference. So that's some of the earliest features of the tool. I hope it makes sense to everyone. It really changes the way that you can go and debug a problem when you've got this kind of interactive functionality. So let me just clear everything away here. Let's say we were having a problem with a diode. Okay, just one of these simple diodes over here, something I'm sure everyone on this call could go and diagnose no problem. So we know we've got a problem with the diode. We're trying to investigate it. So we click on the component. Oh, okay, here we go. Let's get the specs. All right, there's all the specs for that diode. So now when I go and take my measurements, I can make sure that we're within them. If you need more, like I just showed you, you've got the data sheet. And now you can go and create the nets attached to each pad on the diode. So we can create our first net, no trouble. And then we can come down, create the second net, see where that goes. And now we're ready to go and do some probing. So what I'm actually going to do is use our freeze button right here. So this is going to hold the camera, but we can still go and interact with the image. So now that we have it frozen, we zoom in and we can say, oh, okay, no problem. The diode comes out to this test point right here. So I can actually probe both the nets using that single test point. And then you could go and diagnose the issue. So that's a lot of time and context switching saved, because now you're just interacting with the hardware and finding out exactly where you need to measure. And if you had to explain to someone else how to go and diagnose this diode, this tool is going to be your most efficient way to do it compared to going and marking up other drawings.
Yeah, so Eric, you mentioned this really, Eric, or whoever in the chat just said a really good to-do. Add thermal camera, cross with temperature rating of parts, set up violation. So very interesting point, and you kind of read our minds. So FLIR actually reached out to us about 2 months ago, and we're actively working on some hardware integrations with guys like FLIR, maybe a famous logic analyzer company you may have heard of that's kind of trendy, and some other tools like that. But hardware integrations are directly a part of the product roadmap. And essentially, we want this tool, and we're making this tool to be the lens through which all hardware interaction, debug, rework, assembly, etc., is done. So essentially, that's kind of how it works. So somebody asked, how does all the info get into the Board Explorer? Is it imported from Gerber's netlist or actual project files? So kind of a medium. We don't, the tool does not support or take in native CAD data, so we don't take information directly from your Altium file. We don't take your actual Altium file, but it also doesn't take just pure Gerber's. It takes a mix. So it's a standard manufacturing output from Altium, Cadence, etc. It's kind of CAD agnostic. IPC 2581B or Gerber X2 with extended comments from KiCad. And then right now we're almost done with our Eagle direct integration. So you can just put your Eagle files in natively, and it'll just parse and crunch through that and allow you to kind of then overlay and sort through all the different nets, components, layers as you see them on the left. You can adjust the color of the overlay. So if you had a red board, you don't want a red overlay. You can actually go and change that to any color on the wheel and any different brightness throughout that to make it really, really intuitive what you're looking at. So it's a pink overlay. You can't mess that up. But Mike, I think that should have answered your question, yeah, in terms of it takes IPC 2581B files, crunches them, throws them right in, standard output. And the other beautiful thing about that is, so one of our customers, the way that they use the tool is actually with their production shop in China. But now he's like, dude, I've saved 2+ flights over the last couple months because I don't need to send the direct file and sensitive data to them. I don't need them to have an Altium license. I could just put it into this tool, share it within our private cloud, just kind of make them available. And then from there, they could just walk through the board directly with me, or they have the board in front of them and they're on Zoom with me doing exactly what we're doing here. Okay, highlight this, probe this net, read me what you get. Take your DMM, probe this, walk through things remotely. Huge game changer in ways that people can interact on hardware remotely. So how good of a zoom for a small 0201 size probing does the camera have? Great question. So pretty good. You can get all the way down to get your thing done. But like we mentioned, the freeze feature is really powerful for that reason. A lot of people actually go in and freeze the board once you have a sense of where it is, put it under the microscope. We don't have direct microscope support yet. Right now, it works with the 4K webcam or with your standard iPhone camera, tablet, Android camera, no problem. And you could zoom in pretty far. So digital zoom on a 4K camera is pretty good. And it's actually probably even better than this. Is just the lighting in this particular room. Once you get it set up, it's even better.
Yeah.
But that's how it works. So certainly for a 402 and even 0201, you can get all the way down there. I think that's an 0201. That might be an 402. But anyways, it gets down there. And you can always freeze it, go into the microscope, and then kind of do any small scale assembly or rework you have to do there. But
on mobile, freeze is your best friend, because then you can also free up a hand and really get in there and do some work. And so we do a dot release every 2 weeks. The newest feature this week is this kind of zoom in the freeze mode. So we do add some pretty big features every 2 weeks to keep developing the tool.
So someone also said, anonymous, the demo boards I've downloaded don't appear to have component AVL information, so I cannot demo the datasheet feature. Am I missing something? You're not missing anything. That is largely a function of the partners that we work with. Some boards have them, like the Arduino, I believe we actually went in and added a bill of materials custom because they had a kind of messed up one online. And a lot of the SparkFun ones, they did add the bill of materials, correct?
Yeah, that's right.
But then you'll find some boards just don't have them because the creator didn't have them available, or we emailed them and they're still working on them. If you have a bill of materials, or if you found one, shoot us an email and we'll add it in, no problem, to the public version. That's no questions asked. It's an easy one.
Yeah.
But you're not missing anything. It's just the boards you selected. So I would say is find a couple of the more popular boards or the SparkFun or things like that. Even if you don't have the physical board, you can pull a top-down picture of it up on your computer and just do it. So how does the software handle the alignment automatically, or does it require fiducials for the AR to work? It actually handles it automatically. You do a one-time calibration step that's basically a photo of the front and back, and then it'll recognize that board thereafter when you pull it into that project. Yeah. And we're showing people that now, but actually it's going to get even better with InspectAR 2.0. We're doing more of a 3D scanning, and it'll be even cleaner. So it's going to be really impressive when it's at the next stage, but it works perfectly fine as you see right now. But the next one's going to be more of a 3D scan. So even with flex boards, it'll work even better. And at crazy angles, when you have them set up on a stand, it'll work even better in enclosures, stuff like that. But right now, it's just a photo. It'll recognize it, and then you can move it around from there. Someone's like, this is all great. How does the cost exactly work? So right now, we're actually running a pilot program. And a big part of that is we're a small team. We're 10 people. We sold this to a lot of people the first month, which is cool. And I'm like proud to say that. And then the second month, it was me answering emails nonstop from all the customers who gave it to, saying, hey, how do I do this? Hey, what about this feature? Hey, what about this? And I'm like, man, we can't actually do anything more with the business because I'm swamped with the few customers that we just locked in immediately. So we started a pilot program, and that's what I'd encourage everybody to kind of check out and sign up. It literally, your guys' time on this call is probably costing the company the same amount as the pilot program. It's $300 flat, like one time, unlimited users. So I don't care if you have 50 users, 100 users, technicians, EEs, firmware engineers, as long as they're in the same kind of email list, they're in your org, you can get them all to sign up, and it gives you a couple months of access for 300 flat, and then we actually roll that price back in. The pricing model thereafter is going to be likely in the range of a few $1,000s but like per organization, not per person. And it's set up more on a per board basis, meaning if you use it for 5 minutes for your technician or like 2 hours to set up instructions for your EE, it doesn't matter. It's all on the board that you're already ordering. And we have some pretty interesting kind of subsidies that we can discuss more offline separately with advanced assembly. So as you start using advanced assembly for boards, you can kind of waive the price of this tool overall. especially for new customers. So stuff that we could discuss, but basically that's how it works. Far cheaper than an EDA tool. You don't pay per seat. It's just for the whole company, kind of like a lab tool that you'd buy. ODB++. So IPC 2581B compliant. That's correct. Not ODB++ directly, but IPC 2581B. These are all great questions, guys. Thanks a lot. And for everyone else listening, hopefully they're valuable.
Yeah. And I guess one really cool thing that I could show you guys right now is some of the features that we have built in to make taking measurements a lot easier with this tool. So I'll just clear everything away. And we have this great search UI here. So we can search for any neck component or layer. It's really helpful. You can go and make a batch overlay. So we can just go and batch select 5 resistors, and you can just create them. And you can do that by value too. So you could say, show me all 10K resistors, and it'll just pull them up on the board. The other really cool feature that we have that ties into measurement more, if we go and we need to connect to ground to take a measurement, which is incredibly common, so that will work just fine here. And you can see we have the board running live right now. It's still going to track even if you were putting a scope probe or something in here. But what you see right now is really too much information for you to go make a measurement. So to get around that, we do have a transparency slider right here. So now you can see underneath, see what you're doing. It improves it a little bit more, but the real core issue is that there's just this overlay is too busy. So we actually have this really cool edit menu where you can go and say, okay, I need to make a measurement on the top layer, so I want to connect to the nearest ground point on the top layer. So you can come in here and say, don't show me any other layers except for the top. Let's just go and turn them all off. And then you can say, well, I can't probe a trace, so don't show me that. Turn off vias and turn off fills because they're too busy. And now when we go and save this, all you're seeing right now are pads connected to ground on the top layer. So right away you can go in and find your nearest ground point to go and take a measurement. And that's one really, really powerful feature of the tool.
Yeah, are there any other questions about that? I was going to jump into a really quick presentation, just now that you guys have some context on kind of where this tool goes, because it's a little bit beyond just using it to highlight stuff like an EDA tool over, because that's the principal element of the business and of the tool. But it goes beyond it being a really integral part of your workflow management and assigning issues and tasks to other people, especially if everybody's remote right now. How do you kind of make sure that people are doing the right stuff and make sure you're giving them the right instruction besides, here's this board that you didn't design, do this test, I hope you do it right. So keep throwing out your questions in the Q&A. I'm just gonna briefly share my screen and walk you guys through where our heads are at with the tool. You guys can see this, right, Liam?
Yep, all good.
Okay, cool. So basically, this is kind of a pun that we have internally, but engineers, pretty much everybody on this call, the result of your good and hard work is that you've increased the bandwidth for communication, travel, anything. Like before, something this size to transmit information, a piece of paper, you can only get as much information as you could write or type on this thing. But today, you could do way more. I mean, you can show videos, it's unlimited, the amount of information you can transmit with something that's exactly this size. And so engineers have done a lot of that great work. Bandwidth has increased tremendously, but they're still using the lowest bandwidth methods of communication to get their jobs done and to collaborate with other people in the field. Hey, Liam, when I escape, do you see the whole screen or is it still in like full mode?
I do now. I can see you escaped now.
Oh, okay. I'll just stay back in there. So this is the problem. Now, I can't read the chat anymore, but I don't know if anybody has put like a +1 or a thumbs up or something, or in the QA, if you can kind of relate to this at all. This is what people's labs are today. So I used to be an electrical engineer at Tesla and Taser, and Liam was actually one of the earliest engineers at a company called Neuralink, Elon Musk's crazy brain company. So, together, plus other people on our team that worked at Apple and a bunch of other companies, you got 7, 8, 9 different screens, all displaying relevant pieces of information, but it's fragmented and it's difficult to share that with other people that are not explicitly sitting with you in the lab. And I think this problem has been magnified or been made more clear because of the quarantine and the recent coronavirus situation where everyone is not together. You can't walk over. So how do you get all this context and walk people through things cleanly without sending crazy emails and files transferring, not securely, doing things like that? I want to well, we'll go through that after. This is the other problem. Now, we'll show this to some people that don't necessarily get it, but I think most people on this call will know exactly what this picture is. This is an old board that I've actually worked on. This is what we do with pretty much every board. You go on Altium or whatever your EDA tool is, and then to give instructions to a technician or another EE or firmware engineer, anybody, you go into like Microsoft Paint and you take a screenshot, and then you go add a bunch of notes that are totally unilateral. It's just like a one-way thing that you're writing, like place 10K resistors here, cut this trace, add this 3.6 volt Zener, but you haven't linked it to any bill of materials. It's not directly tied to the board itself. There's a bunch of different vias and pads that somebody could mistakenly go over by a pad or a pin. And there's no way for you as the person delegating this task or this work instruction to actually check, hey, did anyone get to step 1, 2, 3? Where do people generally stop off? Where do I need to do a better job? And how can I tie this back into my design file at the end of the day so it becomes a really circular process? Because the whole thing is just totally fragmented. Past the design stage, goes to the manufacturer. After manufacturing, goes to your desk. But there's no real way to tie them all back in. So that's what we kind of built this tool to be. It's a platform through which a lot of the physical electronics work is performed faster than ever before with far fewer mistakes, because all the information is in a single place. If I need to know what a particular component is, yeah, it might take me 2, 3, 5 minutes to figure out, go to my schematic, go find the reel, come back and go out to find it again. But add that up over all these different components and different boards, that's a lot of time and a lot of room for error, just on like kind of the small side of examples. But now with this tool, you can actually delegate tasks, build up instructions, click somewhere, figure out exactly what the part is, the polarity, the value, what pin corresponds to what if you need to do a rework operation. It's just intuitive and immersive, and it's all in one place. So the way you do hardware, I mean, you can really start doing it at more of the pace of software, the way you more intuitively do any other operation. It's no longer fragmented. And you guys can kind of see this playing similar to what Liam showed you. It overlays every different part of the design, including the bill of materials and data sheets, et cetera, all onto the board itself. There's no more ambiguity. You could share the screen with other people to walk them through a test instruction or an operation on the board or where to probe. A lot easier than sending an email to like TI support and taking a screenshot and making all your stuff totally publicly available on their E2E forum, as an example. So this is rarely where the value proposition comes in for the business. Saves people time and money. And that's what it really comes down to. It's going to save you a lot of time. And ultimately, it's going to save you money because, AA guys, close your ears, but hopefully you might not have to go do another respin because you catch errors up front the first time. You're able to delegate tasks across more people because you don't need to train everybody and give everybody an Altium seat. They could just intuitively use the tool and be walked through it. And you can collaborate across regions. So it's just a much more efficient way of doing some of the hardware. So that is the presentation. Yeah, it's going to be available for replay. Could it be run to AOI type? So somebody had a really good question about AOI. So that's actually where a part of this tool is going. Now, the way AOI generally works today, they're incredibly expensive machines, not for any great reason, and they're bulky, not for any great reason, but because it's just the way it's done in the industry today. People are willing to spend 100K plus, and they all require pretty much a golden board. Even some of these new AI companies, they require like 30 pieces to get your board right. That's useless for an MPI operation. You want this thing to work with just the one board that you're prototyping with and directly correspond and correlate and I guess reference against your actual design file. So yeah, I guess what he said is some part of that is we have to get the training data in aggregate over kind of time. And then we're able to kind of do a smart AOI type thing, optical inspection, where it knows, hey, that's a bad solder joint, or hey, that should be DNI, but it looks like there's physically something there. Flag it for the engineer to review. But that's more of a machine learning model and kind of some of the computer vision things that we're working on, but not directly something right now, but like you said, within the roadmap for sure. So yeah, that's totally there. And the QA, so yeah, sorry, might have missed it. Does the tool support custom PCBs? Totally. A lot of this information is available online, but basically it works with IPC 2581B files. So CAD agnostic, supports Altium, Cadence, Eagle, KiCad, I guess Zukin, pads, all these other tools. as long as it outputs the standard kind of manufacturing file format. And as far as like ITAR restrictions, so actually in a few weeks, by the time you guys got on the pilot program and started playing with it, you'd have access to this. We're actually launching on device, meaning no internet connection, ITAR restrictions, I mean, totally within spec because you don't upload these anywhere. But even today, totally safe. It's 2020. The cloud is arguably more secure than your guys' internal your service. So that's a whole nother thing. Every other enterprise software is like this, but totally on device. We solved that problem. And we actually have some military customers today, which can't necessarily name, but big on the East Coast, do a lot of missile defense, things like that. And they're using us today in the lab with a lot of their technicians and things like that. How does it handle more complex products with a lot of through-hole components? For example, switch mode power supply. Totally great question. Kind of handles it the same way you're seeing today. It doesn't really matter how many components are on. We've had 12 plus layer boards with 2,000 to 3,000 components. You could put a probe over it, or I guess Liam's using a screwdriver in this case.
Yeah, sorry guys, working from home, but
yeah, we're all working from home. But you can even change the transparency so you can see what's underneath if you want to see a particular complex pad. But no problem with through-hole components. It'll just reference and overlay exactly, so it's a lot easier than using your design file. And you could change the color of it depending on what your tool is.
Yeah.
For whatever
and
color.
normally it's just going to pull in the exact same colors that you use in your design stage. But if you need those to be different, you've got the ability to change them.
So someone actually said, hey, crazy future thinking. One could model the performance of the board and virtually probe the board and debug firmware without the hardware. So that's actually kind of the way, somewhat, I guess step one of that is we're going to work on integrating some of the simulation data. We're working on this, some of the CAD tools like Cadence and Fusion 360, another amazing tool to kind of work with them and pull simulation data onto actual parts. You can click on a particular net, like, I don't know, a PWM net, IO, GPIO from one of your main micros, and it'll actually show you what's expected, and then you can reference that against the scope measurement. Once you get the scope data integrated in, that's none of the hardware integrations we're working on. Take a screenshot, upload that to Jira, your workflow management, version control, things like that. Any recommendations for AR glasses this might work with? So, you know, that was one of the early considerations when we started, and we actually went the other way because AR glasses, as we've seen, are not a great way to go because that whole business model was so finicky. Magic Leap, prime example. All this money in VC, and now they're up for sale at a way lower valuation than what they were kind of registered at. It's just hard to build these businesses. So relying on them was way too risky. And also, yeah, why have somebody buy a $2,000 plus AR headset or whatever that may not be around to use our tool that's immediately valuable by just using a screen? But also a big part of that is you want to be able to have a screen so you can interact with it, have it all there without moving your head around, just easier in any lab setup, constant. Liam actually had some good thoughts on that too.
Yeah, just my 2 cents on the AR glasses debate is that with this tool where it's specific to electronics, we could get way richer features if we just had like a 2-camera setup. So you have your web camera, but then a really good microscope camera that lets you zoom in really well and do the work that people are used to doing.
Someone said, what about detecting shorts, opens, or backwards parts? So again, that's part of like the next level that would be able to actually visually take input from the board and say, this is not referenced against the design, something's off, flag it, and then go smarter than that, flag it for a short or flag it for a backwards component. But 2 things to that. 1, if you use advanced assembly, you'll never have a backwards component. Everything's going to be done perfectly. I have to say that, but it's true. And 2, no, but I guess there's nothing else that'll do that for you in your lab right now, really, anyways, especially for the vast majority of people that don't have a machine while you're debugging or giving it to other people. So this will make that process that you're currently doing a lot faster when you have an issue on your board to backtrack, compare it, highlight it, see what pin 1 and 2 should be. Are that, you know, is that actually what's happening in real life? Probe it. The way of doing things a lot faster. So
we will have a feature coming for like diode polarity, just one like small subset of that over the next few months.
Yep. So a lot of this stuff is coming, but this is the kind of feedback that we want. So again, it works with your custom PCBs. The free version right now works with a bunch of preloaded kind of sponsored boards from people like DigiKey, SparkFun, CrowdSpy that we've worked with that have expressed a big interest in getting a lot of their boards up because some of the education modules that we're building up with those folks. But if you want to use it with your own boards, you could sign up for the pilot program. Basically, it's like a free trial for a few months. Technical support, US local only. Honestly, like we're all founders in the startup. There's 10 of us. I mean, founders and early employees. We'll stay up as long as you want. If you have a call at 3 in the morning and you have an issue, I will probably wake up and support you. And that's honest, like true. 10 people at the company, if you're willing to give us a shot now and play with it, I'm going to give you 100% support and attention. So that's how we kind of operate it. Personally, I tried the Viewfind display. Theoretically, it should work. Practically, the mount that comes with the display is sloppy and flops around. It's an exercise in frustration. Oh, that was Mark saying it to Eric. Yeah, I don't know. But so yeah, technical support will support you. But the easiest way is just send us an email. We can guarantee you'll get an email response back within 24 hours. If it's a bug you uncover, we'll go ahead and fix it. And again, like as people start to find stuff, like just keep sending it over. But play with the free version, download it online. I'm really interested with a personal project and professional side. How do you handle the confidentiality of clients, cloud-based software? So I just went over this a few minutes ago, but obviously people are coming in and out. So for all the hobbyists out there, so basically the way that this is done, in a few weeks, we're going on device. So there's no internet connection. It doesn't matter. But right now it is cloud-based, but it's not on our local private servers, fully encrypted on device, fully encrypted in transit using DigitalOcean, which has servers in US, similar to like AWS GovCloud. I mean, totally secure. We don't have access to them. It's legit, but we're going on device in a few weeks, so that's not even a concern at all. And then for all the hobbyists out there, right now, we're working on, basically, if you have an open source board especially, just email us and we'll put it on the platform. So like the Orange Tree from Greg, that's a popular board that's going on right now. We put that one up. Actually, Liam can show you a bunch of the boards that we put up recently. If you have an open source board or something like that, just email us and we'll put it up. So not only you, but anybody can use it on the free version. We did this from some folks at Stanford, MIT, and then these are some of the private boards that we have internally maybe that we've worked on. But then Liam can show you some of the sponsored boards if you look at the screen. These are all boards that you can go in, download right now if you have it on your desk or even if you have a picture of it. But the subscription-based, honestly, for hobbyist open source, not too interested in charging you guys to use it because I want you guys to get a feel for it and play with it and kind of grow the user base anyways. And so that's kind of the way that we're going about it right now. And the only thing we really ask is let us put that board up on the public platform so anybody can use, and or we may charge a flat fee to just put it up on the platform, like a few $100, not even, but then anybody can use it. So it's kind of a community model. But that's today, if you just email us, we'll make sure you can use the tool. Simple as that. And then you can sync it like that. It takes a minute. And then it downloads the files. Usually comes with default calibration. Goes like that. Now the pricing model, once you actually want to use it professionally, after you go through the pilot, it's generally you have tiers of like, okay, 5 boards per year, 10 boards per year, unlimited boards per year. And through that, you get unlimited users, unlimited devices, things like that. And it's in the few $1,000s range and upwards, but in that range. It's not in like 50K plus, unless you're a massive organization like Intel and you want to scale this for a lot of your technical support, which we may or may not be involved with right now, but things like that. I haven't seen the website yet. Can you show the hardware you get when you make a purchase of the tool? Oh, yeah. So there's really no hardware. I mean, isn't like you can use your phone or a tablet. We recommend you get this 4K webcam off Amazon, but it's only like $150 one-time thing. If you're buying the tool, we'd work it out, and honestly, like we could find a way to just ship it to you. There's no problem.
If you guys look at my video feed right now, I've just got it, my webcam hovering over the setup in front of me right now.
Yeah, so someone said for hobbyists, if I don't have a board to become an open source project, in which case it sounds like you might be a professional version or somebody using it because it's private to you. But even so, honestly, just email us. If it's a single board here and there, we'll work it out. I mean, guarantee we'll give you significantly discounted prices because you're not part of an enterprise and organization. You're personally paying for it differently. But more than likely, I mean, the trial period, done deal. So just email us at here. Those emails, shoot us an email with any questions you have, any boards you'd like to get on the thing, or if you want to try and pilot it, and we'll get you guys access, no problem. That's a done deal. That's great. So yeah, these are all this is what your projects page looks like. And then you go through a really quick calibration step. That's one time. If you have very different lighting conditions at home than you do in the lab, you may want to do another calibration, but then it's saved forever thereafter. So that's kind of how that works. And we'll overlay the silk screen so you orient it right, correctly. and then you can kind of go from there. So you might
That's right.
spin the board around.
Yeah. So on this board here, you can tell just by the outline and the silk screen that I had it in backwards, but now you can see the silk screen's lining up. It's got to be in this way. You zoom in, does not need to be perfect at all. You can have it off just like this, and then you'll take a picture. Boom. Now what you have to do is confirm to the software where the board outline is. So you just these boxes, and then do the same for the other side, and then it's calibrated.
And then I wanted to show them just one thing real quick.
Sure. I'll stop sharing.
Sure, yeah. And then I just wanted to show to anybody getting on right now, if you download the free version today, for example, this is a simple board, just it doesn't matter. But I'm going to use SparkFun as the golden example here. But basically what SparkFun's done is, so you can see my screen, ignore my 5 million tabs, I'm under quarantine, it happens. But basically SparkFun, pretty much any of their products, certainly all the boards that they have up in our tool that we've preloaded, you can go to the actual product page, and we're adding links to them on the website. Actually, we have them right now, but you can just Google it, find it out. They have nice top-down images right here, top and back. And so you can actually go in and just put your phone up to this and play around with it. If you want to just get a feel for the AR, how it overlays, what a calibration's like, but you don't have a board, just calibrate to this picture and then you'll be able to do one-to-one. So that'll work just fine if you don't have a physical board. Same goes for any of the boards you have, things like that. But actually we're releasing this new feature soon as well, kind of called mobile ECAD. So even your Altium stuff will be available without AR at all. So
imagine a little button right here where you can just go and view the design really quickly from mobile, maybe interact with a few issues, just in the sense of a viewer.
So basically the first mobile viewer for Cadence and everything else. Hey, and one last thing that we wanted to mention for everybody that's still here, please, right now, similar to the way you're doing with this tool, I guess, yeah, Liam, show them this thing and then I'll show them what we're doing with our side.
Oh, well, I was just gonna have this up as background, so you can.
Yeah, let me share my screen real quick. So guys, InspectAR is one of the sponsors, but so are some big players like DigiKey, Microchip, Keysight, obviously Advanced Assembly, Royal Circuits, teachmepcb.com. This is a new course, first of its kind, where we're going through the full fundamentals of PCB design with a lot of the actual electrical engineering theory that someone like me and a lot of people on this call would appreciate and maybe benefit from. And so, you know, a lot of people are saying, hey, you're at home, you're quarantined, or wherever you are in the world. You probably have more time in your hands in front of your computer than you did before. Hopefully you're staying safe. But this is a good way to kind of grow your professional development. It's completely free. And so just go sign up right now, check it out. And we're making badges and we show you kind of how to do full PCB design, like through the schematic capture, layout, in all the different tools. So Altium, Fusion, KiCad, they all have modules. And then thereafter, we're going from there. So afterwards, geez, I'm kind of losing there. Once you guys play around, that we show you what happens when the boards come back to the shop and how to debug it using InspectAR. We have more of an actual module than what we showed you with this kind of webinar demo today. So that way you'll get a chance to see it, interact with it, be guided through it, and also get a sense that, you know, I know there's some people in education on this call. This is a really good way to think about, okay, especially right now in the next semester. So I know people at like Stanford, UCLA, Harvard, all these different schools, no one's coming back for spring semester. And so if you're an EE professor, what are you going to do? And I hope it's not, or it's the traditional way of getting people in the lab and showing them stuff, unfortunately, is not going to work. But how do you keep them engaged? How do you keep people interacting with boards? And how do you keep a track or sense of, are people actually doing this correctly? Where do I need to focus my efforts? InspectAR is a perfect example on where to do that. Because now you can do exactly what we're doing with Liam. You can host a digital lab and you can walk them through the board instead of saying, okay, open up this file. Do you see what I'm seeing? There's no confirmation versus, let me highlight the 3.3 volt rail, probe here, here, here. They can't mess it up because it's the same for everybody. And so that's something I really want to encourage anybody in education to do. Get InspectAR, get in touch with us. Let's figure out how to integrate it into your curriculum. And we will be happy to guide you guys, offer tutorials, demos to any of your students, etc. But something that we totally want to do. So check out teachmepcb.com. to get a kind of first glimpse in the course and how you can maybe pitch that to a lot of your students or anybody else in that space, or any of your other colleagues, or whoever wants like a free primer, some professional educational development while we're all kind of at home. And then thereafter, happy to help you guys out.
We are really, really looking to make a difference in the educational space, especially in light of recent events.
Yeah. So does anyone have any other questions as we kind of come, I guess, towards the end? A lot of people, pretty much everybody stayed on through the whole call, so I really appreciate it. Thank you everyone for your time. But does anyone have any other closing questions? Head to inspectar.com. Links have been kind of all over. Shoot me an email if you have any questions. I'm happy to do this demo for your guys' team. If you want to try it out with your board and then do a demo with that, send me an email. We'll get you guys set up with a trial license and a pilot, and then we'll go from there. But totally something that works. Yep, those are all the links, and totally good place to work together. I got one final question, it looks like. Yeah, it is available on PC. So that's the pilot version. So the free version was to get people a sense, but this is totally where it's used on the PC version for professional. Thank you, Rob, for the kind words. I know that you've recently signed up. I think I actually tried calling. Yeah, I called you today or yesterday just to get on the phone and say, hey, let's do this demo. Understand your guys' workflow. But same thing applies here. Shoot me an email. Let's get you guys set up with the pilot. Because of coronavirus, we'll extend it a month or two. No worries. Try it out for a couple months. If you like it, let's figure out how to get it into your workflow. If you don't, we'll take care of you and make sure that, like, you know, at least you got something valuable out of it. But totally legitimate way to get you guys' projects moving, work remotely while everybody's at home, keep the hardware development going. And yeah, it works PC, Mac, all the platforms on the professional version, which you can get a trial for. Just sign up for the pilot. And online, you can go to pricing. It'll take you to the pilot page. There's no money to be exchanged there. You just have to fill out your form, schedule a demo one-on-one with us for sometime in the next 2 weeks. There's a calendar there to do it right away. It'll just lock on everybody's calendar. And then we'll get on a personal call with you guys and your team and understand what's your workflow, how many boards do you design, what's your board's general technical makeup, like how many layers, what's the size, etc. And then based on that, we can kind of figure out, okay, what's the best way for you guys to start integrating this, walk you guys through it, and then give you all the support you need. But totally involved. We have some big name customers right now that that are using the tool that I can't necessarily name, but one of them makes probably the most popular toothbrush in the world. Big customer, and then customer is building some cool rockets down in LA and some other things like that. So people are doing stuff all over the world. Try it out. It's given people a lot of, I guess, benefits and advantages, saving time and money. And I think that'll be the case for your guys' teams too. So with that, any other questions, we'll just be hanging out for the next few minutes and we'll go from there. So what's the specific camera you recommend and the arm holder to position it over the board? So we can actually link to that. It's a Logitech Brio. I'm going to throw the link up right now. So, you know, as this company grows, invest in Logitech stock. And then let me share this right now with everybody. So this is the camera that we recommend, 4K, USB 3.0. This requirement is actually going to go lower. So meaning we're going to expand the number of options soon as our AR goes to more of a scanning model rather than needing a high-res photo for the calibration. So it's only going to get better, allow you to use it with more platforms. But right now, pretty much every customer that we've had and uses us in a professional setting has had no problems to buy this. If you do, email us, find a way to make it work for you. This is the clamp that we recommend. Oh, shoot, Mark, I think I was just sending this to you. I don't know why it's been doing this. I'm sorry. Let me share this again. Thanks, guys. Yeah, just sign up for the free version, sir, and then just play around with it, show people on Arduino, and just sign up for the pilot. It literally, you guys, everyone's time on this call, I'm telling you, costs the company that you work for more money than the pilot program for a few months. No brainer, try it out. Enough for us to kind of run our business and feel like you have skin in the game. Give us feedback. Every single piece of feedback that you write to us, screenshot, more than likely we'll have it resolved within the next 2-week dot release. So really appreciate everyone's time. Thank you, guys. You know, the questions are still kind of coming in, so we'll let them, but this has been really great. Maybe let it go for another 4 or 5 minutes, Mark and Lisa, I guess till 11:50. Does anyone want to see anything? Did anyone come in late? Leah, maybe just show the board and kind of show stuff so it might spur some questions.
Here it looks like we lost Liam.
Yeah, he just.
Oh, he's back.
He lagged back now. But yeah, just throw the board up there so maybe it might spur some last minute questions from anybody still listening in.
Absolutely. Oh, let's come around. Do some zoom. Some freeze here, zoom around really well. This is a great feature that we just put out this week. I'm really happy with it.
Yeah, it looks great. Daryl did a great job putting this out. Yep, it's overlaying on the pins exactly 1-to-1. You can see all the different spec about that part as you highlight over nets or pins. It'll highlight it on the board so you know what pin 5 is and where it goes. What are the size constraints? There aren't really size constraints beyond can you fit it under the camera, but you can move the camera pretty far up and digital zoom pretty far in. So yeah, we have customers that have used the board with over 10-inch boards by 10-inch. We have certainly the majority of our users are probably within like this size and 2 to 3 times. The field of view, yeah, it's kind of the constraint, but again, even that's going to change as we go to more of a 3D scanning method of calibrating it. But obviously the lighting in the room is going to change and you can zoom in from there. Layers, it doesn't matter. It's just whatever in your design file. So you can have 2 layers, 12 layers, 16 layers, no problem. Yeah, we have a YouTube account. Actually, the best place, just go to InspectAR.com. And if you go here, you can actually go to all their videos. You have first few minutes with the tool. So what I recommend is go download the free version. The second you do that, you'll get an automated email that has all the different links to, hey, your first few minutes in the tool, how to calibrate, how to use the ARC, and what all the buttons do. We've gone through and developed a really comprehensive kind of support documentation set. So go through that and that'll help. But yeah, thanks for your questions. But basically it doesn't matter how many layers. And you could set different colors for the layers. You can have them pull directly from what the standards are. Exciting new tech. We'll definitely link into the pilot program. Yep, decreased troubleshooting time a lot. Thank you. That's awesome. Thank you, sir. That's the whole point. It's going to save you a ton of time, especially for more dense boards that don't have silkscreen.
Yeah.
What's C5?
Right.
What the value of C5? It doesn't matter. Just click on it or search for the value that you're expecting for the part, and it'll highlight it. So it does that really, really well. And you can actually add in. So one of the things that we've done for some of the education market, like with the Arduino and stuff like that, is you can actually make custom overlays that have instructions on them. Liam, do you have the Arduino up, or maybe my picture might be the best way to do it?
I have the project. I don't actually have a physical Arduino with me.
Oh, and I guess you're using the webcam, so you don't have a picture. Just do it quickly for anybody on the board. And neither do I. No big deal. But
I mean, we can show the menu part of it, just where we have the block diagrams and stuff there.
mm-hmm.
So if we go under here under custom, we have a block diagram and a pinout made for the Arduino. Those previews are super small.
Actually,
but,
I could show them right here. Let me show you guys right here. So if everyone is looking at my screen now, this is something that we did for the Arduino that was not or is not a part of the original design file, but you can actually go in and edit it and have it overlaid. So the second somebody looks at this through the lens or through the screen or whatever, you could put instructions here. You could put nice block diagrams. So for education or just for general onboarding or for test instructions or whatever, when you give it to a technician or a student or anybody else, you can have them immediately, hey, here's the board, here's the power delivery, here's the SPI, here's the different like UART comms, here's the JTAG programmer, and just kind of have an overview of the board. You can say, okay, step 1 is circle this, probe here, probe here, probe here. Way easier when it's directly on the board than, and you know, when it's tied to components, they can click on, see orientation, polarity, value, write in comments, things like that. And so that's a part of the tool and some interesting stuff that you can do here. But yeah, try out the free version, sign up for the pilot program, schedule a demo with us. It'll be similar to this, except we'll go through it with your boards and your guys' kind of team and your requirement, your questions one-on-one that you might have more private. And we can go from there. That'd be great.
Absolutely. We love to do it.
Yep. Great looking product for launching the issue. We didn't realize such a large issue without the solution. Best of luck to you and your team. We'll try the pilot free version as soon as we can. Thank you, sir.
Yeah,
That's exactly
awesome.
right. why we developed the product. Again, we're all electrical engineers at the company, pretty much. Certainly the founding team, we've all designed tons of boards. We've been involved with Royal Circuits, advanced assembly forever. And it's like, you don't realize, especially in hardware, things are a problem because you've been doing it this way. Products still get delivered, they work. But then suddenly people like advanced assembly come out and they say, hey, I can get you boards in a day. And you're like, well, shoot, I was waiting 2-3 weeks. And I thought that was fast. I can get them in a day now. And now you can order groceries off Amazon in an hour. And so why can't you go and get all your information about the board and like work on it by just clicking and figure things out? Why do I still have to have 4 screens open and all these programs running and have all these expensive licenses to share with my team? It should just be intuitive. And so that's what we've done and kind of the MO that we've built with the company and the products. Yeah, any other questions from anybody? Try out the free version, download it, let us know your thoughts. That'd be great.
All right. Well, Mihir, Liam, I'd like to thank you both for having this webinar with us today. And I'd like to remind all the participants that we're doing a webinar a week for the next couple of months, something to keep you entertained during this shutdown. So if you found this interesting, maybe you'll like our next one on the ABCs of flexible PCBs.
Yep.
So with that, everyone, I'd like to thank you for joining us. Please feel free to reach out to Mihir and Liam, and hopefully we'll see you next week at the same time. Thanks again.
Okay.
Bye.
Thanks.
Thanks, everyone. Yeah.
Pleasure.
Wait, then there's, yeah, okay, cool. Thanks, guys. Is the recording off? Cool. Everyone else is still on the call, I know.
Recording is still active. Lisa's shutting that down as we speak. It just takes a second.
Oh, okay, it says paused. Now it's set to resume.